Hey guys, welcome to Safi Mixed. In this video, I will let you know how to separate the real and imaginary part of data in the form of a table, whether that data is already stored in certain format on your hard disk, or you just want to create that inside Mathematica. However, if your data is already stored in certain format on your hard disk, you were supposed to import the data into Mathematica and then carry the procedure which I'm here enlisting. So here what I do, I want to create the data inside my file. And for that, I have first defined a function like this, a function of two variables, x and t, and the function is exponential. And inside the argument of the function, I have a complex number. So it could have both imaginary part and real parts. For example, I have iota times variable x times variable t. And then I want to construct a data with the help of table command where I keep the variable t as an iterator and I construct a list inside the table from the function in iterator and I iterate the value of time from 0 to 4 with increment 1 and I have fixed the value of variable x to 2. If I run this command, it gives me data in the form of this table, and you see every second element of this table contains both real and imaginary values. That's true for every element. If you look over here, if you look over here, in all these entries, we have real parts and imaginary part. What I want to do, I want to extract the real and imaginary parts of this table and store them into two different data sets. So before I do that, I'm required to know the length of this data. So I want to add the length into a variable m, and I give the length command, and inside the argument of the length command, I write data, and let me run this. So it gives me 41. This 41 means that the number of rows inside the table of the data is 41. So I'll be using this information in my program. So I just add this to the memory of the kernel. Now I start from if function and then I add a true condition. And the true condition is that if length of the second of the data of every entry, I just enter a number two, whether it is two, one, or three, whatever the number it may be. This number obviously corresponds to the number of element inside a given sublist, which is obvious two as we saw. And I ask Mathematica if this is true, which is true, I know it is true, then extract the data into the data set dataset one, and that dataset one I want to make that I missed a bracket over here. That's why it color is red. It is not reading, so I'll add another bracket over there, and now the color is blue, which says that there is no error in the command. Now I construct a table, and inside the argument of the table, I again construct a list, and I add data, and then I extract the information of all row into the command I, and then I say that you extract the first element of every sub element, and then I again add the same information. I ask I, and I ask here that you should extract the second element. In the second element, first I want to extract the real element, so I enclose, so I add that to the argument of a real function. And then I close the curly bracket. This is my sublist inside the table. And then I add the information of the iterator, and for the information of iterator, my iterator is now I, and it starts from 1 and it goes to 41 as we noted. So I shouldn't add 41, I add m because I have added those information into the variable m at this position. Now let us understand this a little bit. The iterator I corresponds to the number of rows as you see from here, because data extract I means we are extracting the information of row over here, and then this extract the first element of every row and would place it at this whole position. And this information which I am giving here would extract the second element of every row, and then from the second element it will extract the real element or the real component of the data, and that it would do for all rows starting from 1 and going to m, where m I have defined over here, which is length or the number of rows in the data. And then finally I close the if command 2. Now the if function will implement this command because we have given a true condition at this position. So and will store the information into the uh, table data 1. So if I run this, I get things like this. You see now every element contains only the real parts of the data. If I run the data at this position, you will see that you see this element 0, this is in fact this real part at the second row, and here is 1 in the first row, and I have 1 in the first row. So I have in fact extracted the real part at the second position of every row, and I have constructed table data 1. So I close this by adding the memory, and if I check it with data 1, I'll get the same values. So we have in fact stored the information into data 1. Now I copy this and I paste this over here, and I change the name from data 1 to data 2, and from here I remove real and add this to imaginary. So now the f command or the f function will extract the information of the imaginary part at the second position and would construct a table whose name would be data 2. So if I run this, you see now it is black, and if I check it data 2 and I run it, you see, this in fact is the second part or the imaginary part at this position. This is the imaginary part 0198, and this is 0.1986669 here, and here is 0.389418, and that's the same thing as over here. So the I have in fact separated the imaginary and real parts of this whole data into two tables. I can check the plotting of this by adding uh, less plot, the command less plot, and inside the argument I add data 1 or data 1, and if I plot this, the plot of the real data goes like this. And now I copy the same command, and I paste this over here, and I change data 1 to data 2, and I plot this. See now they are out of phase. The real and imaginary parts are out of phase somehow. They are not in phase, you see, in this position. So this way you can separate the real and imaginary parts of data, whether the data has already been stored in certain format on your hard disk or you are creating that here from your list. Thanks for watching.